Hey everybody, I'm Stuart of Stuart Cook Sailing, and just going to have a little chat about surface pressure charts. A surface pressure chart gives a synoptic overview of the weather across the surface of the Earth, and so yeah, listen and watch on, and we'll learn a little bit about how to predict what the weather's going to do. Please add your comments below, let me know what you think, and yeah, enjoy.
So one of the first things that we should be aware of with our surface pressure chart is the issue, time and date. So this was the analysis chart valid at 00 UTC Friday the 19th of February 2021. So this is what was actually occurring at midnight on the morning of Friday the 19th. As well as producing the charts for what was actually happening, they also do predictions as well. So if we turn to the next predicted chart, so that's for in 12 hours time, so T plus 12, and that means it's valid for 1200 UTC on Friday the 19th. So that's midday, so we'll get to that one in a second. Another key element to be aware of on the synoptic chart is that you're looking at a mnemonic projection. So that means you're looking at the world kind of projected through a globe, and so we've got north and south lines, each of our longitude lines here, so they're moving around. So that's running north and south, but so's that. So it's the curvature of the globe, and likewise for east and west, that's our latitude lines. So that's east and west. That's 60 degrees north, 50 degrees north, and 40 degrees north. That's the 40, that's the 50, that's the 60. So surface pressure charts give us a pressure pattern. So that shows us the various high and low pressures that we find over the globe's surface. So we can see over here we've got a high pressure, and we've got a couple of low pressures here, another high pressure down here. Okay, the numbers of each pressure system, that is the pressure in hectopascals or millibars. They're the same measurement, and so we've got a high pressure of 1033 and a low pressure over here of 955, and the point that it's on is a little cross in the centre. And the first thing you will start to notice is that there's lots of lines tightly packed in a circle around the low pressure, whereas there's not so much lines around the high pressure. All these little lines that are interlinking, they are our isobars, and they are lines of equal pressure across the chart. So you can see this line of 1012 following all the way down here. So it's kind of coming from the outskirts of this low pressure up to the outskirts of the high. So that is an equal pressure line across the Earth's surface. Now we're already taking a little bit of kind of knowledge or prior knowledge, and so airflow wants to flow from a high pressure to a low pressure. So the air is flowing out of the high and into the low. But it's not just going in a straight line. The air flows in the northern hemisphere, which is what we're looking at here. We're looking at the North Atlantic. We've got the UK here, Europe, Greenland, and northeastern Canada. So in a northern hemisphere, the winds are going clockwise round a high pressure and anti-clockwise round a low pressure. But the winds are also going slightly out of the high and slightly in to the low. We'll just have a quick little look at that. So we've got our winds doing something like this. And on the high, they're going out of the high. Okay, so we're down here, into the low, into the low, out of the high. So you can see how they start to match up, coming out of the high and into the low there. The key thing to remember with the isobars is the tighter the isobars are together, the greater the pressure gradient. So we're going very quickly from a pressure here of 1000 millibars to say 980. That's happening in a very short space of time, whereas to go from 1012 to 1033, that's happening over a much larger area. And what we have with the pressure gradient there is the greater the pressure gradient, the stronger the winds. So in simplified terms, that means the closer the isobars are together, the faster the wind will blow, or the faster the air will move, basically. So on the steeper gradients, the wind will flow faster, and on the lesser gradients, the wind will not flow quite as fast. It'll be much more of a moderate breeze. We also have various lines on the chart. We have our frontal lines. So we have fronts mainly associated with our low pressure depressions, and is quite a complex kind of bunch of fronts on this specific chart. But what we do have here is we have a warm front here. So this front here with the semicircles on is indicating a warm front. This one down here with the triangles, that is a cold front. And then this one up here with the semicircles and the triangles is an occluded front. Now if you see this, you can get these surface pressure charts in colour as well. Your warm front would be depicted by red line and red semicircles. The cold front by blue triangles and a blue line, and the occluded front by a purple, or indeed a combination of red and blue. You'll always find your warm fronts ahead of the cold front. That's more to do with these low pressure depression creation, and we're just kind of focused on understanding what the fronts are on the chart at the moment. We can see we've got another cold front up over here, and it's chasing in a previous warm front here. What we also see ahead of this front is this little warm front here, but it's not got its line fully joined up. It's got little crosses, and what they represent is that this warm front is weakening, and so it's starting to break up, and yeah, it's kind of no longer a driving force, shall we say. So that's likely to disappear. The other lines that we can get on the chart is pressure troughs. So we've got one here, got one round here, one round here. And the pressure trough is basically, it's an area of very kind of unstable atmospheric pressure, and a kind of very big drop in upper atmospheric pressure. So what that's going to actually bring us is very kind of very sudden cold change. So quite often the kind of the similar weather you'd expect with a cold front, but in a very short period of time and very suddenly. So yeah, watch out for them on your chart as well, especially if you're looking for them coming across where you are. So if I want to have a little think about what this pressure chart is telling me, so if we imagine that we're up here in Glasgow, Scotland, which is about there. This is midnight Friday morning. We're thinking, right, what is this chart telling us to the weather that we might experience? So we've got this low pressure depression, which is out to the west of the UK in the North Atlantic, and it's coming in with a warm front, quickly followed by this occluded front, or indeed the warm and cold front behind that as well. So the first things that I'm going to start to see is is the weather associated with a warm front. So we're going to start to see some high-level cirrus cloud invading from the west, slowly dropping down until eventually, when this front gets on top of us, we're going to start to get some precipitation. If you have a look at just now, the isobars are not too close together. You know, I can open up the dividers here. They're relatively far apart compared to in here. So the same distance of one isobar is now 2 isobars here. So the wind speed from what I've got at midnight is likely going to double, at least, by the time this part of the depression comes up and comes over us. And the wind direction, well, at the moment we're going to be looking at something kind of south-southeast, and we're going to have to think about, right, what's going to happen when this comes across. If this whole thing came across, then it might move around to south-southwest, but we're going to have to look at the prediction as well to see what's going to happen with that. So let's just do that now. Let's move this one out of the way, and let's look at what's happening in 12 hours time. So this big low pressure system has now moved its way across the UK. So bear in mind, this has only been 12 hours and the system's already on top of us. Look at those isobars. They're all tightly packed together, nice even spacings. So you're basically going to have strong wind, and it's just not going to go up and down. It's going to be pretty consistent strong winds, kind of anti-clockwise around the low, into the low, so you're going to have a south, maybe a bit of south-southeast in it. And by midday Friday, you've got this occluded front sitting on top. So you've already had this warm front, which is now weakened. See the crosses? Moved away and across the UK, and now you've got this occluded front. And it's sitting right on top of the west coast of Scotland here. So you're going to be getting just consistent rain, basically. Consistent rain, lots of cloud, and obviously the very strong winds as well. We've also got pressure trough in here as well. Probably not too much of an issue for us in here, but something to be aware of. And you can see the whole speed of this system. But the low pressure itself hasn't really moved. It's more just the fronts. So that's always a sign that we're just going to get front after front after front. They're just going to keep rebuilding back out here in the Atlantic. And you can start to see that happening a little bit down here, where we've got a new growth point here, and we've got a warm front with a dot in it, and the same for the cold front with a dot in it. And what the dot represents is a developing front. So we've now got a developing warm front and a developing cold front. And this is going to turn into basically a new low pressure system. And that's going to track up into northwest Europe as well. So let's take another look. So where are we? So this is our new low pressure system we were just talking about there. These fronts have now formed, but we've also got another low developing, so a secondary low developing just right next to the original one. Again, the position of the low pressure hasn't changed much. Its pressure is still the same. It was kind of 955, 954 before, so it's not really changed much. But we now look at 24 hours later, midnight now on Saturday, and these fronts have moved away. Okay, and we're now seeing no fronts over this kind of western coast of Scotland and Glasgow area, and there's a nice big gap in the isobar. So the winds will have finally dropped. We're still likely to see that southerly airflow, but yeah, much lighter winds now than what we saw during the day on the Friday. So going into the Saturday, we're going to have slightly drier weather, slightly windier, but with that southerly airflow, it's still going to be bringing warmer air up from the south. So yeah, that was a little introduction to surface pressure charts. I'll hopefully do another one soon when we can have another chart to look at, and hopefully look into some kind of different weather patterns that we see on the synoptic chart or the surface pressure chart. Okay. Well, thanks for listening, and yeah, stick your feedback below.